Okay, now let's do this one, yellow. It's really easy. So once again, we have our two crosses, yellows and greens, both heterozygous. So big Y, big Y, little y. What did I do that for? I apologize. I'm getting ahead of myself. That's the double dihybrid cross. So, but we got two big ones, Y, 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 little y, big Y, little y, and little y, little y. It's the exact same thing. It's just with color, right? And so what we have here are, once again, a 3-to-1. Dominant, dominant, dominant will be yellow, 3 yellows to 1 green. Now you can also do a genotypic ratio, the genotypes. That means, what do the genes look like? Well, we have 1 homozygous dominant. We have 2 hetero, or a heterozygous, okay? And then we have 1 recessive. Can't really see that. Let me do this up here. 1 to 2 to 1. That's our genotypic, right? Geno. So that's what our genes look like. 1 homozygous dominant, 1 homozygous recessive, and 2 heteros. 1 to 2 to 1, okay? Or we have our 3-to-1 pheno. Okay, that's how you do a Punnett square. It's very, very simple stuff. And all you have to do is just make up your own cross. Now here's what Mendel did. He was all like, all right, forget this. This is too easy. What would happen if we did a round wrinkled plant versus a round, a round yellow plant versus a round yellow plant, heterozygous. Very crazy. Look at this. Now, I have my legend here for you, and I have started the dihybrid cross right here. Don't look at this right now. Look at down here with me. This is how it works. So we have 2 heterozygous, okay? A dihybrid means 2, okay? So 2 traits. So we have a round yellow, both heteros, crossing together, and a round yellow, again, heterozygous, crossing with another one. So how do we do this? Well, we have 2 little baby Punnett squares. So we have R, and Y, little y. And we have this R, big Y, R, big Y, R, little y, little r, little y, okay? And we do this twice. These are the different combinations, the genotypes, 1, 2, 3, 4, versus the same genotypes. I don't need to do this because it's the exact same thing. So whatever. But we're going to have genotypes right here and here, 4 of these. And I've put them up here. So here's this RY, and here's a big capital R, or big R, big Y. So big R, big Y, big R, little y. All the genotypes that we've discovered from these 2 little Punnett squares go here. Okay? So I'm physically going to take this big R, big Y, and put it here. You see this? And big R, little y goes right here. RY, big Y, littles go there. Okay, and I'm going to do it again with the other cross so we get our different combinations. Once we have those different combinations established in this giant Punnett square, okay, a dihybrid cross, we start looking. Okay, so here's an R, big R going here, big Y going here. Okay, so let me show you this. So we have a big R, little r. Remember, the capitals go first. Big R, little r, big Y, little y. Right? Big R, little y, little y. Little r, big Y, little y. Right? It's the same sort of thing. Little r, little y, little y. So it's different. Before, in the regular Punnett squares back here, we only had 4 different genotypes. When we have 2 traits being crossed together, we have 16 possible. 1, 2, 3, 4, 5, 1, 2, 3, 4, 16 possible traits, which means our ratio is going to be a little bit different. But look at these things. Let's explore this. what we have here is, let's look at the first one. I've got some color here. It's an innovative way of teaching you here. So we have 2 homozygous dominants and 2 more homozygous dominants for the round and yellow. So this pea plant is going to be round and yellow, if you can even see that, right? This is all you see. If you see dominants, you can see round and yellow. That's the dominant trait. Dominant, dominant, round and yellow. Dominant, dominant, round and yellow. Okay? Dominant, dominant, another round and yellow. Dominant, recessive. It's still going to be dominant round, but now this baby's going to be green, right? Dominant yellow, so round and yellow. Another round, but a recessive, which means green, round green. We keep going. What do they look like? This pea will look round and yellow again. Round and yellow. All I'm looking at are the dominants. If the dominants are expressed in the genotype, then you see the dominant trait. Now here we go. We have recessives.
Call 2034, please. Miss Van, call 2034.
Well, I hope she calls. So we got R, homozygous recessive here, means wrinkled. We have a wrinkled yellow pea now because it's still dominant color, so you got this wrinkled one. I'm sorry if you can't see that, but it's supposed to be wrinkled. Once again, wrinkled yellow because it's dominant still. Wrinkled yellow. Oh my goodness, wrinkled. Okay? Dominant, 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 recessive, round, green. Recessive, dominant. So it's going to be wrinkled and yellow. And holy crap, recessive, recessive. It's going to be wrinkled and green. Okay, so these peas, no matter how frail they look, we have our genotypes written up here and the following phenotypes. So what's the phenotypic ratio here? For a dihybrid cross of heterozygous parents, okay, the phenotypic cross, all you have to do is count. Okay, how many round yellows do you see? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? How many round greens do you have and stuff like that? 3. How many wrinkled yellows do you see? 3. And how many wrinkled greens do you see? 1. Always a good way to check. I have 16 possible outcomes, and my ratio adds up to 16. Hooray. All right. The dihybrid cross can be a little bit tricksy, but all it is are 2 different smaller Punnett squares going into the big guns. But this is where you need to start, if I can use my super ability here. Okay? The Punnett Square. This is where it all starts, and this is your formula. Tracing the alleles down, plotting out the different combinations of genotypic results. I truly hope this helped. Let me know. Peace.